Hey there. Just wanted to make a quick video about how the Victron system can peak shave. So that means if you've got, you've got a lot of load. I've had quite a few inquiries about this where, you've got an extra building or a dwelling going onto a place, or you've got a lot of load coming on. And the incoming mains are really not up to the task, and it's a lot of money to replace the incoming mains coming into the property. So it's not unusual now that everyone's, saying, look, we need to be using electric vehicles, for instance. The tiny build trend is pretty cool. So people are putting another tiny build on, and just because it's tiny doesn't mean the load is tiny. You've still got all the things going on. You've got heating, you've got appliances, all that sort of stuff. So I just want to show that how the Victron system combined with a good battery like Freedom One, for instance, you don't have to have something quite this big. You don't have to have 100 kilowatt hours. You could do it with 10 or even 5 if you wanted to. You just have to make sure the battery and the inverters are capable of delivering the required energy and power to meet the excess demand that is above where you're going to limit the grid to. So let's get into this. I'm going to share a screen. Here we go. Share that screen. And so this is, let's have a look. This is my place, and I've got batteries pretty much at 100%. So let's get dropping these batteries down a bit so we can sort of see how they work. Got them on keep batteries charged. So I'm going to go to optimized without battery life for now. And I've also got my Power Genius control system up so I can put some load on. So here's my hot water cylinder. Whack some load on there, and let's put the underfloor on as well because it's not too cold, but never mind. So we got some load on. Now what you can see here is that I've actually got a grid current limit set at 13 amps. And so the grid is limiting itself, and it tries to stay a little bit below that so that it can handle any surges or peaks in load, so it doesn't kind of overcook it too much. So you can change that at will. I'll go to 25 amps. And you'll see it'll just lift up to whatever I set the incoming grid limit at. It will lift that grid set point up to help match the load. Although what I've got here is, because I'm optimizing from the battery, it's preferring to take that out of the battery. So if I just go keep batteries charged, I've also got a 90% limit here. So I'm just going to drop my grid limit down, reset it back to something that's normal, and then we'll get into the details. But I'm just sort of showing you that you see here we can use from the battery up to whatever the grid limit is allowing. Sorry, it's using it from the grid up to the grid limit to manage the load, and then the rest will come from the battery. So that's because I've got the mode to keep batteries charged, engaged. So this is the cheapest way to do it, is to have a small battery. Now the battery obviously needs to be large enough, to handle whatever loads you've got throughout the day. And you can see there your load profile is whatever it's doing throughout the day. And I've had some peak shaving in here where I've limited it at 4.8 just arbitrarily, just as a test. And you can see here what happens to the battery when it starts peak shaving. So when the load is above what the grid limit is set at, starts peak shaving, the battery discharges. So for however long that peak is going to be, you can see the peak over here, however long that peak's going to be, the battery needs to be able to handle what the system's not allowed to draw from the grid. So then we drop this down here again, and it's dropping as it's peak shaving in the evening peak as well. Oh no, that's the morning peak this morning. So that was the evening peak yesterday. And then the battery's staying at 100% state of charge if you've got it set at keep batteries charged. Now, so this is now currently, this is actually peak shaving. So if I drop this back to 16 amps, drop the incoming limit, you'll see here it's dropped the incoming limit, and the load is still the same. And so now we're going to draw some more from the batteries. Now, don't worry about this DC power thing. I've basically got two batteries running on the one system. The one battery's got the BMS telling the system what the state of charge is, and the other battery is simply following. So this is not a measured value. When DC power is enabled, this is a calculated value, which is why it sort of doesn't really match that well, but it gives you an overall idea of what's going on, makes sense of the numbers. So I can do peak shaving right down to, say, 6 amps or 3 amps if I want to. But what that will do is, obviously, it's going to demand more from the battery. So it's going to say, look, I need a lot more energy to handle the peak. And so I'm pulling in 1.2 in from the grid. I've got 7 kilowatts there. So as you can see, I've got 4.5, 5 kilowatts coming from the battery. So my inverter needs to be able to handle the difference between the grid limit. I don't know if you can hear that in the background, but that's the cooling fan on my inverter. It needs to be able to handle the difference between the limit you set and what you expect the actual grid to be doing. Okay, so you don't want to set it too low. If I set it down to 3 amps, it's just going to really drag a lot of energy out of those batteries, and it will discharge the batteries too quickly, and then the full load will be demanded from the grid. So that's the limit. If you're going to set the grid limit too low or the load's too high, then the battery needs to be the right size as well. And there's a basic rule of thumb for that. So what we need to know really is, what are your peaks? This is for calculation, right? What are your peaks? I'm going to turn this back up to 16 amps, something reasonable. So what are the peaks going on in the home, or what will they be? What do you want to set the grid limit at? And that will also, the last number that you need to know is, what is the overall consumption in kilowatt hours per day? Okay, so those three factors are really important. So the other way to do peak shaving is to, so this way of doing peak shaving, where you're keeping the batteries charged, keep batteries charged, that method basically does not allow the batteries to optimize the solar. It may accidentally happen, but it's not going to actually naturally optimize the solar. But it means you can put a battery in that's just designed to shave the peaks off. You don't need any excess battery to optimize the solar. So if you do want to optimize the solar, then you need to do something like optimized, set it to optimized without battery life, or with battery life, doesn't really matter. And then set your grid set point to the level that you're willing, that you want to optimize with. So 80% means you've got 20% to play with as far as optimization goes, but you've got 80% less the minimum state of charge. So in this case, 60% available for peak shaving. Okay, now the only limitation for optimizing using this optimized method is that it won't full noise recharge from the grid when it's lower than its set point. So if I set this up, well, we're sitting at 98%. So let's pull the grid limit down so it demands more from the battery, get the battery down a little bit. So if I set this here to minimum state of charge, let's say we'll set it to 100%. So the minimum state of charge is now set at 100%, and you can see there it's still up. That's still drawing from the battery because this is in peak shaving mode. But if I dump some load off, so I'll dump the load, yes, back to a low load, and also increase the grid limit back to something reasonable. And you'll see here, the only thing charging the battery now is the PV charger. So what I could do is turn that PV charger off, and then we can actually see what the system would look like, say at night time, when the battery is below. See here, ESS1 is that ESS1 mode is below the minimum state of charge. So I'm just in the background here, setting up Victron Connect so I can turn the PV charger off. But my process is going a bit hard, so it may not do that. You can see there the grid is now just keeping up with the load, but there's no excess being used to charge the batteries back up. So using the optimized method is not really that great. There is a third way you can do this, but it's going to require some programming, and in that you could use Node Red to change the incoming grid limit and also change the ESS mode from keep batteries charged. You could change the ESS mode to keep batteries charged at night time, and then you could change it back, say early in the morning, to optimized, so that it captures some of the solar. And you could also base that ESS change and depend it on what the weather's doing or what state of charge the battery's actually at, so you don't let this battery go too low. So you could say, look, if the battery gets below 30%, then change the system to keep batteries charged so that we actually get some charge back into the battery. If it doesn't go below 30%, then keep it on optimized. Those are the sorts of things you can do with Node Red, and that's a lot more in-depth. And yeah, you'd need to get someone who can program that for you in Node Red. I think that's probably enough to explain pretty much how the peak shaving works. But if you want the cheapest peak shaving solution, you're going to leave it at keep batteries charged. And you are going to calculate what size battery you need and what size inverter you need based on these three things. Just as a refresher, what's your peak load expectation? What is your incoming grid limit? And how many kilowatt hours do you expect to use per day? So, and if you've already got a Victron system in place, that's pretty easy. You can just go last 24 hours and go, this is our consumption, 58 kilowatt hours. And then with those three factors, we can't exactly calculate what's going on, but we can. Looks like I've lost that. Okay. Anyway, we can't exactly calculate what's going to go on, but we can limit. We can get a pretty close estimate of what size battery, and you just maybe make it a bit higher, or be willing to bring in a little bit more in from the grid. Okay, so I think that's well and truly enough. See you all next time.